got you.
So we're starting here tomorrow.
Well, we finished
But
where we
tomorrow
started.
today.
Is it?
It is.
And is it tomorrow today somewhere?
Yeah.
Or isn't today tomorrow somewhere?
Is today yesterday?
Maybe, maybe not.
I have heard.
I saw it.
All right. Oh, we got more. I'm sorry you guys lost.
Oh.
Yeah, that's fine.
If you wanted to think, you wanted to kick her.
It's so dark. I was all over this girl the entire game because she was the one to watch. She
Ah.
was in my position, so like I literally marked her every single time. Can I start
You got to spell your name.
Yes.
The pressure.
Yesterday.
How do you make a J? Well, you guys aren't taught how to do that, so.
I know how to make a J. I just forgot.
She forgot the L.
Yeah, we have to start another roll for you eventually too.
Oh, okay. Oh my god.
This is getting ridiculous this year. I'm gonna have to like really move stuff around.
You only do like
It's kinda cool.
this season.
My favorite one
That's
is told
sports
your kids
season.
well, your
Yeah,
I think mine's
those are fun. You know, you can have them when you leave because I know you guys want to keep them.
What did you say? Like you were like Connor, I need you to sign this. So
He's like, oh, that's cool. He was so proud of his new paper. So what we want to do today is we're going to work on writing this backwards, starting with the complex and then writing it in the standard form. So we're going to start with the complex form. We're going to start with the complex form where it was r cosine theta plus I sine theta. And we're going to make it look like A plus B I. It's tricky to rock a rhyme, but not to do this.
Ooh, that's a good one.
I don't get it.
Tricky.
Oh, ha ha. Okay, I get it now. Yeah, I know the song.
This is actually
Now it is me.
this is actually a lot easier going this direction than it is the other way. Okay? Because all you have to do is place yourself on the unit circle and go. So if I'm looking at the first bit here, we start with, well, what is the cosine of negative pi over 3? Negative pi over 3. So we start with this. Negative pi over 3 is in which quadrant? Fourth quadrant. It's in the fourth quadrant. Cosine in the fourth quadrant, is it positive or is it negative? It's positive. What's the reference angle for a pi over 3? 60. So we have a 30, 60, 90. And what's the cosine of 60? 1/2. And it's going to be positive because it's in the fourth quadrant. Okay? So right now we have square root of 8 times, well, 1/2. And now I do the same thing with the sine value at negative pi over 3. Well, we already have it placed in the fourth quadrant. Is sine positive or negative in that fourth quadrant? It's negative, good. What's the sine of 60? So it'll be a negative root 3 over 2. Everybody with me so far? What's the square root of 8?
2 root 3. The square root of 8 is 2 root 2. And then I have times the quantity 1/2. I'm going to write it as minus I root 3 over 2. You okay with that?
Yeah.
Last thing I do, distribute 2 root 2. So you get, I'm going to do long form just so you guys see what's going to happen here. You get 2 root 2 over 2 minus 2I. What's root 2 times root 3? Good.
what I'm, from here,
Oh, okay.
from here to here, and then I'm just gonna distribute in. And I'm just doing long form because now I'm gonna be able to simplify my fractions. What's 2 over 2? 1. And what's 2I root 6 over 2? Gonna be I root 6. So my final answer then is just root 2 minus I root 6. When you're working backwards in these, it's just a matter of placing it in the quadrants, using a reference and bouncing it around to get your trig values. If it doesn't fall into a perfect triangle, or a perfect triangle, excuse me, if it doesn't fall into a special right triangle, you just press a button on your calculator and you're gonna get a decimal. That's it. They're really fast. Okay? They're really fast. Let me show you another one. Can I go to another one real quick? Or are you guys still writing it down? Good? Ah. Yeah, 3.75, yeah. The marker got a little messed up. So again, I have 3.75 times the quantity cosine of 3 pi over 4 plus I sine 3 pi over 4. That's the complex, or the trig form, excuse me. I'm going to go back to the complex form. So 3 pi over 4, what quadrant does that place you in? 2, good. What's your reference angle? Good. So we're in the second quadrant. Reference angle 45 degrees. What's the cosine of 45 degrees? Good. Root 2 over 2. We remember that? Now, cosine, is it going to be positive or negative in the second quadrant? Negative. So we know that this first part simplifies out to be 3.75 comes along for the ride. Negative root 2 over 2 plus I. And what's the sine of 45 degrees? Root 2 over 2. Second quadrant, sine is positive. And since now 3.75, that's 3 3/4, correct? As an improper fraction, what is that? What is it? 15 over 4. Huh? And then you distribute that in. Bring that one across because, excuse me, how about this make for a generic rule? If the decimals, halvesies, quarters, things like that, real simple ones, make them into a fraction, distribute in. If they're nasty, just multiply, press a button. Okay? So this one we can distribute in. What happens when you multiply fractions? Just multiply across. What's 4 times 2? 8. So you're going to get negative 15 root 2 over 8 plus I, so let me write it the right way, 15 I root 2 over 8. Technically the I should be prior to the radical. The book puts it usually at the back end. Hey buddy, 2 days in a row, wow.
Dustin.
Great. So exciting.
Wait, so since it's like the same thing, is it just zero?
I know. I'm sorry, I was distracted by text awesomeness.
Terribly me.
Is it like since it's like negative 15 plus 15?
It's 15I. And that happens. You gotta make sure you have that I in there, okay? Because you can't combine them any further. Because if we treat the I when you have it thrown into algebraic statements, you treat it just like you would a variable. You can't combine them any further. Okay? And that's it. So like I was saying, it's a lot easier
to go backwards than it is forward to construct. There's a lot less steps. You don't have to find the radius. You don't have to work through the tangent to find the angle. Here you're just working inverse trading going. So was I okay in assuming that it's easier to go backwards?
Yeah.
Okay. To rock or line.
Once whoever over there said it's tricky, then I got it.
So let's look at multiplying and dividing.
For somebody to sign.
Yeah, no. Yeah, you want to sign this one? Ah! Okay, this looks awful.
Yeah.
Okay?
No way.
It does.
It looks awful. What happens is we're going to be able to take and multiply two trig forms together. And then just label them as z sub 1, and it was, r sub 1, we had cosine theta 1 plus I sine theta sub 1. And then z sub 2, it's just some other
So
trig.
you're just combining them?
Yeah, it works out to be, like I said, there's a very simple formula to write out. It just looks bad. Okay. So you have two trig forms. And when you multiply the two values together, if I want to take these two and multiply them together, all we have to do is the following. Take the radius, multiply them together. Take the cosine of the two angles added together. Plus I sine of the two angles added together. So it looks really weird.
So is it gonna like X this?
It'll say multiply, and it'll give you a value. And all we're gonna do, you're gonna know what these two are to start with. You take the two radius, you write them down. You write down cosine, you add the two angles together.
Okay, so you just combine.
Pretty much. So it looks really, really weird. It just means there's two different trig forms. There's just two values that multiply together.
So I
This is our first set of values, this is our second set of values. It would be really, really easy when I put in, like, throw an example in here, and I'll show you what happens. We'll take these two and multiply them together. Okay? So I know when I multiply the two together,
So it would be I squared.
no, there's no I squared here, because the I just comes along for the ride. All the combinations are going on within the parentheses. You're going to add your theta values together. So you're going to get your two radius multiplied together times the cosine of the two different thetas added together plus I sine of the two theta values added together. So I'm taking 2 times the quantity cosine 2 pi over 3 plus I sine 2 pi over 3 times the other stuff. It looks like crap. Crap? No, it won't be. It works real fast.
How does it move real fast?
Well, all right. It's a matter of adding and combining like terms. Really, really slowly? Yes. Okay. All right. Don't worry. You guys always worry. So here's what happens. When we go through this, we just start labeling in and filling in the blanks. What's our first radius? What's our second radius?
8.
Okay. Excuse me. Thank you. What's our first theta value?
You want the like
5 or 3.
2 pi over 3. We'll just write it out with the radius stuff. Okay. We have 2 pi over 3. Our second angle is 11 pi over 6. And I do the exact same thing with the sine sign. Again, it looks awful. What's 2 times 8?
Wait, I thought it was times, like, in
No, it's a plus sign. It's a plus sign. Right. So we start by piecing it together. We start simplifying each individual chunk. There are basically 3 parts that we're going to simplify. 2 times 8, and then 2 pi over 3 plus 11 pi over 6. We're going to add those together. So we wind up with 16 cosine 2/3 plus 11/6. It's the same thing as 4/6, 11/6. We get 15 pi over 6. And isn't it convenient that's exactly what the next fractions add together?
That's always good.
Because it's all, yeah, because it has to. Because they're the same, you're only adding the 2 things at the same time. You're not going to get different, you don't get different thetas. Okay, so it's, again, it looks daunting, but as you start peeling it back, the steps are pretty straightforward. Oops. Bad graph. So now we're going to start simplifying this and this. 15 pi over 6 simplifies to what fraction? Good. As you start spinning it around. Because if you simplify 15 over 6, you get what? You get 5 over, well, let's see, divide both by 3, you're going to get 5 pi over 2. Which is, you start to think about where does that get placed. 1 little, 2 little. Was it 2.5 pi? So you wind up at pi over 2. What is the cosine at pi over 2? Sorry, I'm going to move this up here. So we have 16 times 0 plus I times, what's the sine at pi over 2? 1. What's 16 times 0? What's 16 times I? Get your answer. What happens here is that when you're dealing with your theta values as you add them up, you're going to add them together, and you're going to try to figure out where they land and find the cosine and the sine value of them. If they don't land on a special spot, you just press a button on your calculator. They're going to land on somewhere in the unit circle, and if they don't land on a clean spot in the unit circle, you have to press a button. So you're going to land at one of your reference angles, okay? And if you don't, press a button. Okay. Do another one. All right. We'll do another. Or do you want? Actually, you know what? Since we're a little short, I'm going to show you the rule for division, because you do basically the same thing, but there's a subtraction. Okay. And then we'll come back because it's the same generic setup as you go through. I'm going to do the division one. Okay. Same properties, same look to this, but with division, instead of adding the thetas, subtract them. Instead of multiplying the radius, what do you think we're going to do? You divide it. So the division one, not the division bell. Pink Floyd reference, you guys don't care. Anyway. The division one
Yeah, it's still gonna be a plus in the center. You're gonna go through the same basic scenario, aside from when you divide, you're subtracting the theta values. Okay? I'm gonna write it. Are we all good on the smartboard? I'll put it up on the smartboard also for it. Nice puppy. So if you want to divide two complex numbers, or trig forms, excuse me. Let me show you an example. We're going to divide and it'll tell you specifically, divide this by this, or it might even write it out, 24 cosine 300, blah, 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 over the other stuff. Correct. Yep, correct. The first set of values are your Z1s, or Z sub 1, excuse me. The second set is obviously the second set. So as we start the problem out, all we're going to do is start piecemealing it together, just like we did the multiply problem. You fill in the blanks with everything that you know. In fact, you're given everything to do. It's a matter of direct substitution. What's my first radius?
24.
Second one?
8. Can you just like automatically make it 4?
Yeah, if you want. It's fine. So I'm going to get 24 over 8 because they couldn't get away from the buffet.
Ha 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 ha. 24 over 8.
That's what he said. That's right. That's what he said.
Oh!
I'm so confused. Sorry, Dennis. Usually it's me who doesn't get it.
Like it overate, like it ate too much food.
Oh.
So it stayed at the buffet.
That looks like
You're 2 for 2 for today for this 2 for 4 2.
She's just like, oh, wow.
you got this. That's all I did.
Very good.
I mean, I laughed a little bit when you first said it.
Are we okay substituting it then? What's 300 minus 75? 225. What quadrant does 225 drop to? Third quadrant. So let me move this up a bit. So right now we're at 3 cosine of 225 plus I sine 225. So we plot 225 to get its reference angle. 225 goes to the third quadrant, reference angle of 45. Cosine, positive or negative in the third quadrant? Negative. What's the cosine of 45? So it'll be root 2 over 2, but it'll be negative 2 root 2. Excuse me, root 2 over 2. Excuse me. So it's 3 negative root 2 over 2 plus I
again, sine is negative second in the third quadrant, so we wind up with a negative root 2 over 2. Distribute out the 3, and your final answer becomes negative 3 root 2 over 2 minus 3I root 2 over 2. And it's negative here because this was a negative here. Don't freak out when you see solutions and if you're checking them in the book or in the solutions manual. The book usually writes this as 3 root 2I over 2. I don't like that, with the I on the outside. I like to put it in front of the radical. It's technically where it's supposed to be.
Are we ever gonna like get rid of that?
Yeah, if it's not a special rectangle, let's say this wound up as 200, what would you do?
Put it in the calculator.
Put it in the calculator and get the decimal. It's quite literally, if it doesn't drop to a special triangle, press the button.
I think that's gonna make things easy.
It's a mixture. So, as I said, the multiplying and dividing part, it looks like it's going to be horrible. But I honestly think that there's less work here than there was trying to find the radius, the absolute value, multiplying out, find the tangent, do all that other stuff. I think there's less work here because it's a matter of spinning it to the correct quadrant and filling in the blanks. Okay? We okay on those? So tonight, let's do I think this is the day 2 of 6-5. But I want you to do also 35 and 40. Because we didn't do those yesterday. That's the going backwards from the polar form to the trig form. Or excuse me, trig form to the polar form. We didn't. I asked because you just didn't see how to do it yet.
Oh.
So that's why I was like, hey, don't worry about those two yet. I'll show you how to do those first thing tomorrow.
When did we do those homework? Long time ago? The galaxy far, far away? Go to another one at all? Maybe.
Okay.